magic potion that brings people back to life on TV? What if I tell you particles in the quantum world interact in a similar way? To demo, I'll have to bring about an atom. You see, the nucleus is made of neutrons and protons, which are further made of elementary particles called quarks. Neutrons have a taste for the heftier negatively charged down quarks, while protons for the positive up-flavored ones. Neutrons are pretty erratic, though, as sometimes they'd intrude into others' businesses or just venture out solo. Life lesson time, folks. There are consequences to your actions. Because of their larger masses, physics demands their extra energy be broken down. Their instability leads to a special guest, the W-negative boson, which embodies an extraction of a negative charge from the neutron, which can transform a down quark into an up flavor, hence creating a proton. Minus a negative is a positive. This is beta decay, which also produces an electron and an electron antineutrino by balancing out the charges and lepton numbers. Now that's a weak interaction right there. Part of the three fundamental forces described by the Standard Model. Its force carriers, W and Z bosons, facilitate interactions while conserving important properties like charge, energy, etc., oftentimes through reliable neutrinos. Oh, and not to forget, it is literally the reason we exist today. High energy, suitable conditions on the sun's surface increase the impact of these interactions. Two hydrogen protons through the weak force create deuterium neutrons, which can combine with other protons to create helium, which is nuclear fusion. So, antiparticles are the opposite charge but the exact same mass, and it has long been believed and experimented that in different ways, if a particle is switched off by its antiparticle, things should work fine, until its location is also mirrored. This is the CP violation, one of the biggest questions of particle physics, arisen through countless weak force experiments in the 1900s. The incorruptible physics laws we experience as matter beings do not apply to particles that exhibit CP violation, which explains why there's an abundance of matter as compared to antimatter in the universe. So how much do we know about the Big Bang?